Alright, lesson 2, weather patterns. Vocab. High pressure system is a large body of circulating air with a high pressure at its center and low pressure at the outside of the system. Low pressure system is a large body of circulating air with a low pressure at its center and high pressure on the outside of the system. Air masses are large bodies of water that have uniform temperature, humidity, and pressure. Fronts, a boundary between two air masses. Tornado, a violent whirling column of air in contact with the ground. That in the ground part is very important. It's not a tornado unless it's on the ground. Hurricane is an intense tropical storm with winds exceeding 119 kilometers per hour. And a blizzard is a violent winter storm characterized by freezing temperatures, strong winds, and blowing snow. Alright, so we're going to start with pressure systems this lesson. High pressure system again, circulating pressure in the center of the air. Air travels away from the high pressure while dense. Then it sinks. This leads to clear skies and fair weather. So high pressure systems lead to clear skies and fair weather. So on a day where you have a track meet, you want to be underneath a high pressure system. Low pressure systems have circulating air with low pressure in the center. Air travels towards the low pressure, and the rising air cools and condenses. So as the rising air cools and condenses, it leads to clouds forming and precipitation. We talked about how clouds form already. Here's a pretty basic picture, and this is what you're going to kind of see for highs and lows. So here you have something called convergence and divergence. We're not really going to get into those too much, but convergence means that things are coming together, and when they get down to the bottom, they're diverging from each other, so they're going apart. So in a high pressure system, we have warm air coming, we have air coming down and then spreading out. In a low pressure system, we have surface air or surface wind coming to the low pressure and then being pushed up. Air masses. Air masses occur when a high pressure system lingers over an area for several days. The sinking air hits the surface and takes on the temperature and moisture of that area. Air masses are classified by where they are formed and their temperature. So, continental air masses are formed over land. Maritime are formed over water. Maritime, like marine. Tropical means that it's going to be warm. So, you could have a tropical maritime air mass. That would mean that it's warm air formed over water. Polar means it's going to be cold, and Arctic means it's going to be the coldest that it can be. So here we have maritime tropic air masses, again over the water and in warmer areas. So this is going to come from the south. Maritime air masses will have more humidity, more moisture in the air because they're coming from water. Continental tropic air masses will be from over land and from more of southern latitudes, and again here we have more maritime tropics. So here's maritime polar. So this would be fairly cold and has quite a bit of humidity or water vapor in the air. These two right here, we have Arctic air masses. That's going to be the coldest, and so it's not going to hold very much liquid, very much water vapor. Here we have continental polar. Same thing. That'll be cold, a little warmer than the Arctic, but still cold. And we're back to maritime polar over here. So these air masses are kind of what affects the weather that we have. That's why we stay pretty consistent with the weather that we have as far as on a year-to-year basis. Fronts. Major weather changes occurs at the boundaries of air masses. So where two air masses meet, we have major weather changes. There are four types. Cold fronts occur when cool air moves towards warmer air. The cool air forces the warm air up. As the warm air rises, it condenses and leads to storms and rain. The temperature drops and it can become gusty. So this is what we're looking at. We have cool air is moving from behind the front. So this line right here is our front. If we see a map, we're going to have these lines, the little triangles. That means it's a cold front. So Because the cool air is moving behind the warm air gets pushed up because it doesn't have anywhere else to go. And as it's pushed up, it starts to make those clouds. Because again, when it rises in the air, the temperature decreases with altitude. And then we have the condensation because the dew point is reached. Warm fronts occur when warm air moves towards cooler air. Warm air glides over cold air, which creates a wide blanket of clouds, leads to a steady rain, and temperature rises. Stationary fronts occur when one side is warm and the other is cold. They do not move as quickly. They still move, but just not as quickly. Leads to cloudy skies and light rain. So here would be our warm front. So we have warm air from behind the cold front. As it meets with the cold front on this side, it's just going to rise right above the cold front. So here we had our cloud development. Warm fronts are character, or when we make the symbol for warm fronts, we're going to have these our little half circles here. You can think of them as half suns. Here's our stationary front. Again, it's just a cold front and a warm front meeting. It's going to give you a stationary front, and this right here would be our symbol for stationary front. Last one, occluded front. When fast-moving cold air catches up with slow-moving warm air from behind, it leads to precipitation. So our occluded front, we have advancing cold air from behind the front, receding cold air ahead of the front. So what happens is we don't have anywhere for this air to be pushed. And when that happens, we have cloud development form way over top. A lot of cloud development here. And you'll see for the occluded front, the map symbols has the triangles and the half circles on the same side. Alright, severe weather. This is going to be our last big heading. We're going to go over some different things. But thunderstorm has 3 stages. The cumulus stage, this is a cloud formation, a cumulus cloud as a matter of fact, and has updrafts. Those updrafts are very important. During the mature stage is when the cloud is formed. Downdrafts occur. Those downdrafts are accompanied by heavy rain, or heavy wind, and lightning. The dissipation stage, so this is the stage where it's starting to fall apart, the updraft stops. So that updraft is really what keeps the thunderstorm going. The winds die down and there's less precipitation. Lightning is caused by ice crystals that rise and sink, causing them to crash. That creates a positive charge and a negative charge in particles. Air molecules rapidly expand. Okay, so before we move on to what creates thunder, so this difference in a positive and negative charge, we want to ground that out. We want to have the same things. So we move from positive to negative, and then that's what our lightning looks like. Air molecules rapidly expand and contract. That's what creates thunder, is when they expand and contract like that. So here we have our 3 stages. We have our cumulus cloud, where we see our updraft. During the mature stage, we still have that updraft, but now we also have a downdraft. And the dissipating stage, there's no more updraft, we just have downdraft, and there can be wind and air moving out these directions as well. So here's how lightning is formed. We have ice and water particles separate, negative charges fall to earth, positive electricity rises from the ground. When the two join, when two join and hit the ground, that's when we have our lightning actually happen. And there are different kinds of lightning. You can have cloud-to-cloud lightning, you can have cloud-to-ground lightning, and you can have ground-to-cloud lightning. So cloud-to-cloud will obviously be within the cloud, and you can see that. That's actually pretty cool looking lightning. But the big lightning strikes that we like to think of, some of those can start in the clouds, and some of them can actually start in the ground and work their way up to the cloud. Severe weather, some more. Tornadoes, formation. When thunderstorms, updraft starts to rotate, winds spiral, forming a funnel cloud. It's only a tornado when it's on the ground. So funnel cloud is in the air, tornado is actually when it's touched down. Tornado alley is from Nebraska to Texas, caused by cold air from Canada meeting with warm, moist air from the Gulf of Mexico, creating ideal conditions. Tornadoes are classified by the Fujita scale. F0 would be light damage, just breaking branches, nothing too crazy. F1 through F4 is going to be more damage as the more you go up. Some of these can derail trains and tear roofs off. F5 is incredible damage. This can like demolish concrete and steel and really, really, really bad things. So here we go again with the tornado formation. If warm, moist air rises from the ground, warm air meets cold, dry air, a vortex is created descending from the storm cloud. Vortex makes contacts with the ground. Updraft draws more air, rises upward while rotating. The tornado spins at speeds, creating a destructive force in its path. So if we're going through this over here, here we have our updraft, and we have that the vortex with the descending air coming through the bottom of it. Hurricanes. Hurricanes are the most destructive storms on the earth. They're typically over water in the late summer. They can be up to 150 times larger than tornadoes. Formation. Warm, moist air rises, making a low pressure system. This creates a tropical depression. The tropical depressions have thunderstorms. As the air continues to rise, it becomes a tropical storm. After that, anything with winds above 190 or 119 kilometers per hour is considered a hurricane. So those are just the progressions it goes through. First it's a depression, then it's a tropical storm, and if it gets to that powerful of a storm, it can be considered a hurricane. They dissipate once they're over land or cool water because they don't have that warm, moist air causing the low pressure system in the middle of it. So here we have warm ocean water provides energy for the hurricane and causes more evaporation, making humid air and clouds. Wind coming together to force air upward. The wind flows outward above the storm, allowing the air below to rise. So instead of air just coming up and then falling back down, it comes up through and then flows out. Humid air rises, makes the clouds of the storm. And the last one, light winds outside the hurricane, steer it and let it grow. Winter storms, we're fairly familiar with these in Nebraska. Snowstorms, blizzards, very, very low wind chills. Ice storms can cause slick conditions. They can actually tear down power lines and trees as well. And our last slide, severe weather safety. The U.S. National Weather Service issues warnings and watches. A watch means that severe weather is possible. A warning is when severe weather is occurring. So a tornado warning means they've already seen one. Tornado watch means that it could happen. That should do it for this lesson.